Hey everyone! Today I'm diving deep into the fascinating world of direct online starters or DOL starters for induction motors. If you're an engineering student, this is something you'll definitely want to understand. So let's get started. First up, what's the purpose of a DOL starter? Simply put, it provides a safe and efficient way to start and stop an induction motor. It's designed to protect the motor and electrical systems from overcurrents and short circuits when starting. Now, how does it work? When an induction motor kicks off, it draws a very high current, about 6 to 8 times the rated current. This happens because there's no back EMF initially. A DOL starter connects the motor terminals directly to the supply line, allowing full voltage to hit the motor instantly. Let's break down the key components of a DOL starter. First, we have the main contactor. This is an electromagnetic switch that connects or disconnects the motor from the power supply. It's activated by the control circuit. Next, the overload relay. This little hero protects the motor by disconnecting it if the current goes beyond a preset limit for too long, preventing overheating. Then, we have the start and stop buttons. Press the start button and the contactor coil energizes, connecting the motor to the supply. Press the stop button and it disconnects. Simple, right? Don't forget fuses or circuit breakers. These provide protection against short circuits and abnormal voltage conditions. And finally, push buttons or selector switches for manual control. Now, why should you use a DOL starter? It's simple, minimal components, straightforward operation, and it's cost-effective. Plus, it's reliable with fewer parts to fail and offers high starting torque since full voltage is applied. But there are downsides too. It draws a high starting current, which can cause voltage dips and affect other devices on the same line. Also, the sudden full torque can wear out mechanical parts faster, and it's really only suitable for small motors below 510 GP. Let's talk operation. To start the motor, press the start button, the contactor closes, and the motor gets full supply voltage. Once running, the motor stabilizes at full load speed with normal current. The overload relay keeps an eye on the motor current. To stop, press the stop button. The contactor opens, disconnecting the motor. DOL starters are perfect for small pumps, compressors, fans, workshop machinery, and conveyor belts. But for larger motors, you'll need something more advanced like a star delta or soft starter to handle the higher starting current. That's it for today's deep dive into DOL starters. If you have any questions or need more details on specific components, drop a comment below. Thanks for watching and happy engineering.